Hello, calculus students. We are going to be doing unit 7.6 today, working with separable differential equations. So I'm going to share my screen and you can look at the presentation while I go through it. We're going to jump right into some examples. So hopefully you have your note guide handy and you can look at that. All right, so example 1 says, rewrite each differential equation with the variables separated. On your notes handout, you should see the whole procedure that we do to do this. So what you're trying to do, first of all, is get dy dx by itself. If the derivative is written as y prime, one of your first steps would be to write that as dy dx and so forth. All right, so I'm going to start with this first one. Grab my pen here. And first of all, since I want dy dx by itself, I'm going to move x squared to the other side. So in this first example, I have 3y dy dx. Whoa, that was a crazy pen. Equals, and that would be negative x squared on the right. All right, our next step is we want x's with dx and y's with dy. So I have 3y here with dy, and I'm going to move dx to the other side. So that gives me 3y dy equals negative x squared dx. All right, and that's how we would write it in its separated form. All right, let's look at the next one. So again, my first step is to rewrite y prime as dy dx. It just makes it easier to see what needs to be separated there. And so it looks like I just need to, well, I've got an x here, x here, x here. So I'm going to first divide by sign. So that gives me dy dx is equal to cosine x over sine x. And then I would leave dy by itself on the left. And this would become dy equals cosine over sine dx, or if I wanted to get real fancy, I could make this cotangent x dx. All right. On C, our dy dx is here in the numerator, so I'm going to rewrite that as x dy dx up there over e to the y plus 1 equals 2. All right, my first step then, or second step, is to multiply both sides by e to the y plus 1. So I can get that dy dx lower. So that gives me 2 times e to the y plus 1. All right, I'm going to move the dx over at this step, and hopefully you can kind of see where we're going with this. And then I need x's with dx and y's with dy. So I'm going to divide both sides by x to bring x over here. And I'm going to divide by e to the y plus 1 to get it over with the y. So I would have 1 over e to the y plus 1 dy is equal to 2 over x dx. In general, if you encounter things like constants in these, you want to keep those on the right. If there's some numerical value like 2x, keep it on the right, right? Don't move the 2. You want to have the left side where the y is as simple as possible, and any extra things put over on the dx side. All right, let's look at another example. It says, given dy dx equals x plus 1 over y, find the general solution. So we're going to be looking at 2 things today. We're going to have general solutions, which will involve the case where we have a constant or a c. And then we're also going to have particular solutions, which is where we can substitute the value in for x and y and determine our c. So we have general solutions and particular solutions to differential equations. To solve both of them, they start out the same way. We're going to do that separation that we did in the examples. So in this case, I'm going to multiply both sides by y to get y over here, multiply both sides by dx to get dx on the right. So this would turn into y dy equals x plus 1 dx. And hopefully you were okay with me doing that all in one step, right? The x plus 1's over here, move dx over there. When this y comes to the other side, I'm multiplying by y, so it's y dy. All right, at this point, we have separated. Once you've separated, your next step is to integrate both sides. So I'm going to take the antiderivative of the left and the antiderivative of the right. So antiderivative of y would be 1/2 y squared, or y squared over 2. The antiderivative of the right would be 1/2 x squared, or x squared over 2. Antiderivative of 1 is x, and we put our constant on the right, right? Keep your constant on the right here. All right, next step, I'm going to multiply everything by 2. So now I have y squared equals x squared plus 2x plus, and when I multiply a constant times 2, it is still a constant. So I'm just going to write it as c. You'll see some videos or notes, they'll have this called c1, and when they multiply it by 2, it's c2. It doesn't matter, it's still a constant. All right, I'm going to keep solving for y. So I get y is equal to plus or minus the square root of x squared plus 2x plus c. All right, if you are not given an initial condition, like if we only had part A, I'd be done, I'd leave it like this. How we determine whether it's positive or negative, it is based on the initial condition. So if our initial condition has a negative y value, then this answer here would be the negative version. All right, so we're going to keep going. We are finding a particular solution. I like to plug them in before this very last step. I might even plug in my initial condition here. I kind of do it before things get too simplified. Sometimes it's easier to find your C in that case. So I think I'll just plug it in right here at this level. So I'm going to put -2 in for y. That gives me a 4. I'm putting in 0 for x. So 0 squared plus 2 times 0 plus c. So I get that my c is equal to 4. And so our final answer is y equals, and again, our y value is negative. We have negative square root x squared plus 2x plus 4. Again, general solution, particular solution. All right, let's look at another example. This one I did in class second period if you were there. So this time again, I need to get dx over with x squared, and I need this y over with dy. Now when this y comes to the other side, I'm dividing by y. So it is 1 over y dy. Be careful on that step. I see a lot of students when I'm grading AP exams make that mistake. They make it y dy when it should be 1 over y. On the right side, it is x squared dx. All right, this time we're just looking for our general solution. So we're going to have that plus c at the end. All right, our next step is, after we've separated, is to integrate. So I integrate both sides, find the antiderivative. Antiderivative of 1 over y is the natural log of y. The antiderivative of x squared is 1/3 x cubed, or x cubed over 3, doesn't matter which way you write it. And remember to put your constant on the right. All right, I'm trying to solve for y. I want my general solution. So to undo ln, I exponentiate, otherwise known as raising both to the power of e. So I get y is equal to, and this is going to be plus or minus, right? Because I'm doing this absolute value here, plus or minus e to the, and I'm going to write it as x cubed over 3 when I put it here, just so it's not quite so messy, plus c. Now, off to a little aside here, and this was the aside I did in class. I'll go through it again. When you have a situation like, let's say I have x to the 3rd being multiplied by x to the 5th, the rule with exponents is if you multiply by the same base, you add the exponents. So this would be x to the 8th. All right, similarly, if I have exponents being added, that means that this was two things with the same base being multiplied. So this can be written as y equals plus or minus e to the x cubed over 3 times e to the c, right? It had to be multiplied by the same base to get those exponents, and that is an exponent. This is still a constant. E to the c power is still a constant. This would be the case where maybe you want to call that constant subscripted 2 or something, but it doesn't matter. So now I'm going to take that constant and move it to the front. So my general solution is y equals plus or minus c e to the x cubed over 3. I'm sorry, that last step, that was hard to see. That was a 3, and it's hard to see it was an exponent, right? So that's my general solution. A lot of times, anytime you undo these ln's, it's going to look like this form. And some of you may remember from pre-calc, this is our general form for an exponential function like PERT, if you guys remember that one with money, y equals PE to the RT. Or if you're working with exponential growth or decay, you might have y equals, AE to the KT or something where you have that exponent rate times time. All right, we're going to move on to the next example. All right, we have some practice AP problems coming up. So this first one says, which of the following is a solution to the differential equation dy dx equals x squared over y? And they're giving us initial conditions this time. All right, this is a multiple choice question from an old AP exam. So we're just going to start like we would start any differential equation problem. We're going to separate. So y is coming to the left, dx is going to the right. So this should look relatively familiar. We just did this problem very similarly in the last step. So we have y dy. Oh, actually, we had 1 over y, didn't we? So this is y dy. This one's actually a little easier, equals x squared dx. All right. Antiderivative of both sides. I get 1/2 y squared or y squared over 2. Antiderivative of x squared is x cubed over 3 plus c. And again, if you like to write those as fractions in front, that's all good. All right. This would be the step where I might throw in my initial condition. All right. Or I might keep going. And multiply both sides by 6 in this case, right? Trying to get rid of those fractions. So if I multiply by 6, actually, no, I'm going to throw in my initial condition. I have y squared. So we're doing when x is 3, y is -2. So -2 squared would be 4 divided by 2 is 2 equals 3 cubed is 27 divided by 3 is 9 plus c. So my c in this case is equal to -7. All right, so I'm going to go back to this step. I have my, I'm going to check my work here, make sure I haven't made any mistakes. Yeah, I've got my 1/2 y squared here. Y squared over 2 equals x cubed over 3. And actually, I'm just going to multiply by 2. I'm looking at what my answer options are here. And this is now -7, right? Replacing the c with -7. So it looks like I need to solve for y. So I'm going to multiply through by 2 so I can get the y squared by itself. So that's going to give me 2/3 x cubed. And again, 2 times 7, 14. All right, we still have a constant there. And now again, we take the square root of both sides. So y is equal to plus or minus the square root of 2/3 x cubed minus 14. And at this point, we need to decide, if you look, both the negative and positive answers are here. So you need to go back to this initial condition here. And if we look at our initial condition, our y is negative. And so that means we need the negative case. And so our answer choice looks like, finish writing this down, E should be our solution. All right, let's look at the next one. Similar idea, which of the following is a solution to the differential equation dy dx equals 2 sine x with the initial condition y of pi equals 1? All right, this time I just need to throw the dx on the right. Oop, go back, lost my pen. So dy, here pen, there we go. Dy equals 2 sine x dx. So this one looks pretty straightforward. Take the antiderivative of both sides. So integrate the left, integrate the right. Antiderivative here would just be y, right? Because we're left with 1. So y equals antiderivative 2 sine x would be a negative 2 cosine x. Plus c. All right, we're going to plug in our initial condition. So x is pi, y is 1. So 1 is equal to negative 2 times the cosine of pi is negative 1 plus c. So we get 1 equals 2 plus c. So our c is equal to negative 1. So rewriting our equation with the c value replaced, we have negative 2 cosine x minus 1, which looks like choice E again. All right, I think we have one more example. All right, it says let v of t be the velocity in feet per second of a skydiver at t seconds, where t is greater than or equal to 0. After her parachute opens, her velocity satisfies the differential equation dv dt equals negative 2v minus 32. And we have an initial condition of v of 0 equals negative 50. Write an expression for v in terms of t, where t is measured in seconds. All right, so I'm going to jot down our derivative here. We have dv dt equals negative 2v minus 32. And remember, it's usually something times dv and something times dt. So our next step in this case should be factor out that negative 2 so that we can separate. So I factor out negative 2. That leaves me with v plus 16. All right, this v needs to go on the left. Oh, I made that a y. The v needs to go on the left with dv, and the dt needs to go to the right with negative 2. Again, if you have things like constant like this, leave them on the right. Just move things that have the v, or in this case, or a y to the other side. When this v plus 16 comes over to the other side, since it's being multiplied here, I'm dividing by v plus 16. So it is 1 over v plus 16 dv is equal to negative 2 dt. All right, our next step, integrate both sides. We have ln absolute value of v plus 16 is equal to negative 2t plus c. All right, let's put in our initial condition. We know when t is 0, that v of t is negative 50. So we have the natural log of negative 50 plus 16 equals negative 2 times 0 would be 0. And we get c. The natural log of negative 50 plus 16 is the natural log of negative 34. Since we're taking the absolute value, we have the natural log of 34 is equal to our c. All right, so our function is now ln v plus c, or excuse me, v plus 16 is equal to negative 2t plus ln 34. All right, I need to exponentiate both sides. So we have v plus 16 is equal to e to the negative 2t plus ln 34 Again, remember when you see this part of it up there, that's going to come to the front, or I'll just go ahead and split this into its two parts again. Maybe that's easier for you to see. This is now e to the negative 2t times e to the ln 34. Okay, again, when you multiply by the same base, you add the exponents. So working in reverse, if the exponents are added, you can write that as a product. All right, this turns into e undoes ln 34. So we just have 34. So our v is equal to, or excuse me, v plus 16 is equal to, ooh, my pen's going crazy here on my last example, is equal to 34 e to the negative 2t. And we get, and somewhere in here I lost a sign. No, that was okay. I'm just checking my work here, because we should be getting that v is equal to, should be a negative 34. So I've got to figure out where I made my mistake here. e to the negative 2t minus 16. So let's double check. It's not 34. Oh, because we should have put a plus or minus in here when we did this step. Yeah. Plus or minus here. Yeah, and it should have been plus or minus in there because we got rid of our absolute value here. I should have caught that. And so this is plus or minus this. And because our initial v value was negative, this should be the negative case. It should be the negative 34 e to the negative 2t plus 16. All right. I'm just going to show you another way here that maybe it'd be less confusing. If at this level here, before I put in my initial condition, if I had exponentiated both sides here, I'd have v plus 16 equals e to the negative 2t plus c. And I think this is how I did it the first time and didn't have that error in there. Now put in my initial conditions. I have negative 50 plus 16 would be negative 34. And we have CE to the negative 2t. Oops, but we're doing it when t is 0, sorry. So then that's going to turn that into a 1, and we get that our c is negative 34. So you might have caught it earlier if you had done it this way, but just remember here, the step that I skipped, this should have been our plus or minus, and then use our initial condition to catch that sign on there. It should be a negative 34 on that. If you have questions about it, you can ask me in class tomorrow. Didn't mean to make it confusing. Good luck. And again, if you have questions too, you can also text or email me. All right, good luck.